Thank you for joining us today for this webinar. I am Kent Chesky, and I serve as Executive Vice President and CEO of the Council for Agricultural Science and Technology, or CAST. We are very pleased to share our most recent CAST commentary, Gains Foregone by Going GMO-Free, Potential Impacts on the Consumer, the Environment, and Agricultural Producers. As noted on the agenda, we will have a Q&A with panel of authors from today's commentary after our main presentation. We'll be opening up the chat box for questions related to this topic in just a few minutes. CAST is a nonprofit 501c3 membership-based organization comprised of scientific societies, companies, nonprofits, universities, libraries, and many individual members. CAST was established in 1972 at the recommendation of the National Academy of Sciences National Research Council. CAST board is comprised of representatives of scientific societies, agribusiness, and nonprofit organizations. It is through our network of members and supporters that we select our topics for CAST publications and access volunteer scientists, economists, engineers, and other subject matter experts who help produce these papers. Over the last 14 years, over 1,500 professionals have graciously volunteered their time, energy, and experience to serve as authors or as reviewers to help ensure each of our papers is unbiased and based upon sound science. I'm excited to share with you that CAST is kicking off its 50th anniversary in 2022, commemorating a half a century in communicating the science, technology, and innovation so critical to the future of agriculture, food, and natural resources. The observance of this milestone began in late October with the release of a new publication focusing on CAST past, present, and future impacts. In addition, the CAST board is planning a series of presentations, listening sessions, conversations, and other events to be held in various locations over the next year. The culmination of this will be at the CAST annual meeting in Iowa in 2022. We will share more details through Friday notes and social media over the coming months. So hopefully you can join us in participating and celebrating this important event. Today's webinar is being recorded and will be available later through our website. Toward the end of the presentation, we'll post a message in the chat box for you to submit questions to our panelists. The task force for this paper is Dr. Brandon McFadden, Associate Professor of the Department of Agricultural Economics and Statistics at the University of Delaware. His research focuses on food choice and consumer behavior, including the effectiveness of food labeling, genetically modified foods, and additives toward contemporary agricultural production. I now will turn the program over to Dr. McFadden. Thank you for your work on this paper.
Kent, thanks for everything that you've done to help to get us here. Hello, everybody. Thanks for coming today. I'm happy to have a chance to speak with you. I'm going to turn my camera off during the presentation, just save a little bandwidth, but I'm here, okay? First, I'd like to thank my authors, my co-authors, Ellen Goddard, Jayson Lusk, Jill McClusky, Stuart Smyth, Farzad, Taheripour, Wallace Tyner, and Alison van Eenennaam. I'd also like to take a second to thank the reviewers, Graham Brooks, Matt and Quaim, Kim Anderson, and the CAST liaisons, Mark Armfeldt and Gabe Middleton. This paper is dedicated to Wallace Tyner and Wallace Huffman, who recently passed. These two scholars' work on GMOs influenced not only my work, but the work of many others. And Wallace Tyner was also a co-author on this paper. So let me give you a roadmap of what we're going to do today. I'm going to give you a quick background on GMO applications, just very brief to provide some context for everybody. Then I'm going to provide some motivation, some background to give you a motivation of what this, what kind of brought this commentary together. And to try to do that, I'm going to talk about food system challenges and then also public aversion to GMOs. And then finally, I'm going to present some claims made by this commentary. Specifically, I'm going to make the claims and then provide some evidence for them, okay? And so the first claim is that GMO products are safe for consumers and provide benefits. The second claim I'm going to cover are GMO crops offer environmental benefits. And then lastly, I'm going to talk about the slow and unpredictable pace of GMO crop regulations and how that limits investment in research and development. So there's been in the US a framework for regulating GMOs for quite some time. And that regulatory responsibility is shared between three agencies, the EPA, the FDA, and the USDA. The first GMO food came onto the market in 1994. So GMOs have been around for quite some time now. I want to first introduce BT crops and HT crops. BT crops were modified to protect plants from insects, and HT crops were modified to allow the plant to withstand specific herbicides, and that helps reduce the pressure of competing weeds. As you can see in the figure on the right, these crops are widely adopted in the US, and they have been studied extensively. Okay, so that's why we're focusing on them a little bit. They've been studied quite a bit. And you may notice, right, I've got some information. I've got a box here in the figure added, right? This is something I've added to highlight that if you were to look at it, you might see, oh, well, for corn, if I were to add BT corn and HT corn together, that would sum more than 100% of acres planted. And so what's going on there? Well, this is because a crop may have more than one trait, and this is referred to as stacked traits. And most of corn and cotton in the US are planted with stacked seed. So on the left, we have a figure for corn showing the proportion of those acres planted to BT only, HT only, and then the stacked trait. So I will mention some other GMO applications, and I want to put them on your radar now so you have some background. The rainbow papaya was modified to protect the papaya tree from a disease. Golden rice was modified to biofortify rice with beta carotene, which is a precursor to vitamin A. BT brinjal, or as we say in the US, eggplant, was modified to protect plants from insects, but has additional implications because of how BT is applied by farmers who grow this brinjal. And then I'll also talk about the GMO chestnut, which was modified to protect the tree from disease. So now that we have a brief background on GMOs, let me shift to the motivation for this commentary. I'm sure you've all heard about 2050, but if not, okay, the projections indicate that the size of humanity will increase around 25% over the next 30 years. And not only that, but people on average will be more wealthy and demand more calories. And if these projections are correct, then that means we'll need to increase global production by around 30% by 2050. And while it's important to think about the future challenges associated with agricultural production and food needs, we really don't need to look towards 2050 to observe calorie shortages. There are 13.8 million US households in 2020 who are concerned about having enough calories for their families. And around 11% of people globally are undernourished. So agriculture is a major user of resources. And of course, availability of resources. Sorry, I'm not sure what happened there. Okay, so, the availability of resources like land decrease as population increases. Okay, so there's going to be, extra constraints put on some of these resources. So let me take a second to define efficiency, right? Because it's a term that can be used in different ways. and what I'm going to define is what economists call total factor productivity, which is the amount of output produced from a given set of inputs. The figure on the right shows how agriculture output has increased in the US, while the necessary inputs have stayed about the same. This increased efficiency has been driven by public and private investments in agricultural research, and it is necessary for agricultural production to have continued increases in efficiency. Unfortunately, there are factors that reduce efficiency, like agricultural diseases from insects and fungi. And so to come back to that rainbow papaya, the papaya ring spot virus decreased papaya production in Hawaii by over 50% between 1993 and 2006. A GMO papaya, the rainbow papaya, was commercialized in 1998. It was widely adopted and gave Hawaii's farmers a second chance to continue growing papaya. Mycotoxins are toxic compounds that affect 25% of global food and feed, and they have animal and health impacts and cause crop losses. There are also weather effects constraining agricultural production. A recent study estimated that human influence on climate change decreased global agriculture efficiency by 21% since 1961, and that loss is equivalent to losing 7 years of production. I don't have to spend too much time discussing supply chain disruption issues because, thanks to COVID-19, we're all living it, right? We see the impact of supply chain disruptions on food availability and constraints on production. So while farmers have adopted GMOs, the public is leery. But it's very important to remember that most consumers are not closely tied to how agriculture is produced, right? Only around 2.5–3% of the population works in farms or works in the food manufacturing industry. And scientists, right? This figure is from a bit of an older study. It was in 2015 from Pew Research Center, but they found that 88% of members of AAAS, which is the group that publishes science, right? One of the top journals. 88% in 2015, 88% of scientists agreed that GMOs were safe to eat. At that time, only 37% of the public did, right? So there's this gap, both between the consumer and production, and then also people who are very knowledgeable about the issue, and then people who don't have a lot of knowledge. It's important to note that while consumers display aversion to GMOs, when asked in a survey like this, actual purchasing data don't really match this aversion. So for example, non-GMO products make up about 12% of sales for salad and cooking oils, and only 7% of sales for products like ice cream. It's easy to kind of use something like this to pick on consumers or talk down to consumers, but we shouldn't. It's important to remember that people are busy. They don't have a lot of time to think about the safety of GMO foods, or the motivation to go research the science about the safety. And so we've got to meet the public where they're at, and not where producers or scientists would prefer them to be. This image on the left is an example of how the public is currently met with information about GMOs. So take a second, right? Look at this image on the left. Think about how it makes you feel. I know the context behind this image, and it still makes me feel a bit uncomfortable, right? And so imagine, this being shared on social media. It likely invokes some emotion, and that's what it's meant to do, right? It's to invoke emotion, and disgust-based moral intuitions have been associated with public aversion to GMOs. On the right, there's a quote pulled from a report by the UK's House of Commons, and this report specifically mentions misinformation about GMOs and asks that value-based opposition to GMOs not hide behind claims of scientific uncertainty. So, given the challenges the food system is facing, and public aversion to GMOs, the objective of this commentary is to blend results from scientific organizations to highlight the positive impacts of GMO adoption. Much of today's discussion is going to be US-centric. That's simply because the large-scale adoption of GMOs in the US. But when possible, I will try to also pull in a discussion about potential global impacts and the implications for less developed countries if GMOs were removed from the marketplace. A couple of caveats before we proceed. Often GMOs are kind of discussed as if they're one thing, everything is lumped together. But it's important to remember that GMOs are not one thing. There are many possible applications, and each should be evaluated independently. So I apologize, through this presentation, it sounds as though I'm discussing GMOs as a single entity. Two, we are not suggesting that GMOs are a silver bullet. We're not claiming that at all. Solving food system challenges involves more than just seed adoption, but seed adoption is very important, and that was demonstrated by the Green Revolution. Okay, so now that we've kind of given some background, we've got some idea about the motivation for the commentary, let's start looking at the claims made by this commentary. So number one being that GMOs that have received market approval specifically are safe, right? And there's a lot going on in this slide, so just pause for a second, don't strain your eyes, give me a second to provide some context here, okay? So this information on this slide was pulled from a 2016 report by the National Academies of Science, Engineering, and Medicine, specifically Chapter 5. And in this report, NASEM thoroughly looked at the evidence, right, and the effects of GMOs on human health, which this chapter is targeted at. I have paraphrased statements, so I pulled a box from the report, this box 5.1. I pulled it from the report, okay, and I've paraphrased some of it on the right, but I wanted you to be able to see exactly how I paraphrased it, so I'm not taking things out of context. So while NASM was reviewing the evidence, they pulled these different statements made by different organizations, and so here on the right, I've just paraphrased them, okay. So the National Research Council, no adverse human effects documented. American Association of Advancement of Science, AAAS, right? That figure we saw from the Pew Research study, that group, okay? The technology is safe. Council on Science and Public Health, no apparent human consequences after almost 20 years of consumption. The WHO, GMOs are on the market, have passed risk assessment and no adverse human health effects have been documented. The US FDA, GMOs are not grown in the US until FDA questions about safety have been resolved. And the European Commission. The main conclusion from 500 plus research groups that worked on 130 research projects over 25 years is that GMOs are not riskier than conventional breeding. A source of public aversion to GMOs is the corporate control of the food supply. And if you were to think about that as a value-based concern, it's completely reasonable to be concerned about that. Even as economists, right, we often worry about things like market concentration and market power. However, we have to do something to incentivize investment, right? And the costs aren't trivial, okay? So the cost to get a GMO trait to market will average 136 million for the applications to be approved. And those numbers were collected on traits that were approved from 2008 to 2012. And it's also important to note that patents don't last forever, right? And investment and innovation would be greatly reduced without the ability to protect discovery and development of new technologies. Moreover, the benefits and investment of innovation are received by more than just the biotech or seed companies. The table on the left presents results from studies that examine the distribution of benefits from the adoption of GMOs. Benefits to companies and farmers come from the increased net revenue, and benefits to consumers in the rest of the world come from decreased prices. So if you can, just take the first 3 rows of this table from Price et al. 2003, which examined the benefits of HT cotton, soybeans, and HT cotton and soybeans and BT cotton. And the total benefits from these 3 crops in 1997 alone sums up to 750 million, okay, in benefits. And the pie chart on the right we have here summarizes the findings from these tables, okay? And so as you can see, US consumers receive 20% of these benefits from the GMO innovation, and farmers receive 31%. So while there's understandable concern about this, the companies aren't the only ones receiving the benefits from the innovation. Also, BT applications have major health benefits to farmers in other countries. The image on the left is likely how we imagine pesticides being applied to crops, because this is how it occurs in the US. However, backpack sprayers are often used to apply pesticides by many farmers across the globe. And of course, using a backpack sprayer, right, to apply pesticides increases farmer exposure to these pesticides. Adoption of Bt brinjal in Bangladesh, and this is a recent study, decreased the toxicity of pesticides by as much as 76%. Also, the yield protection that was provided by the Bt brinjal allowed these households to maintain more brinjal for consumption while increasing net revenue for the brinjal that they sold at market. Bt cotton reduced applications of the most toxic pesticides by an average of 70% in India. And Bt corn reduced the presence of mycotoxins, which have negative animal and human health implications. GMOs can also increase the nutritional value of crops, and you may be familiar with the story of golden rice. If not, golden rice is targeted at reducing vitamin A micronutrient deficiency, which disproportionately affects pregnant women and infants, and children with vitamin A deficiency are more likely to be stunted and thus overweight and more anemic. There is evidence that golden rice can effectively decrease vitamin A deficiency if substituted for currently consumed rice at high rates. So this study found that if it were substituted at 70%, then it could decrease the prevalence of vitamin A deficiency by 55 to 60% in women and by about 30% in children. So aversion to golden rice by NGOs prompted a group of Nobel laureates to compose a letter rejecting the opposition against golden rice. And the last sentence of this letter asks a daunting question. How many more people in the world must die before we consider this a crime against humanity? The letter was signed by 107 Nobel laureates, and I added that little bit, the 107, the blue text, because I couldn't fit the signature page on a slide, but it was signed by 107 Nobel laureates. And those laureates would likely be happy to know that golden rice was recently approved in the Philippines after many years of work by the International Rice Research Institute. So now, with that last claim, I think I've provided some evidence that not only are GMOs safe, but they can help protect human health and add nutritional value. So I'm going to move on now to claim 2. So another source of public concern about GMOs are their possible long-term consequences on human health, on the environment. And rightfully so, right? Because it takes a lot of resources to feed and clothe all of us. For example, agriculture is the largest user of habitable land. And so we have to think about this and realize that if yields are lower, right, more land will have to be used for production. And that's including bringing land into production, okay, from other areas that are currently used for things like forest or pasture land. And so not only are we, agriculture is a large user, but the less efficient we are, the more land we'll need to use. So a point of debate has been whether GMOs protect yields, increase yields, or both. And so let me explain this a little bit. I understand this can be confusing. So, if you think about the BT and HT traits that I've talked about thus far, they are part of these reducing factors in this image on the left. So this image on the left, I pulled from that 2016 NASEM report, okay? And so GMO applications protect against reducing factors like weeds, pests, and disease. And what that does is that reduces the gap between actual yield, right, the yield that a farmer receives, and the potential yield, given that all the growing factors were perfect. Additionally, something I haven't talked about here, but is occurring. So there are also applications targeted at limiting factors, okay, like drought tolerance. And there's recent research that seems to indicate that GMOs also help control for weather effects. So as the new traits come along, moving not just from reducing factors, but also to limiting factors and defining factors. So this figure on the right illustrates how corn yields in the US have steadily increased over time. And that increase, that steady increase, has been thanks to investments in agricultural research. The red line in the figure shows, the adoption of corn, GMO corn over time. So this study tried to, provide some evidence about whether or not GMOs increase yield, but they went an extra step than previous work has done by controlling for weather factors and then also soil characteristics. And after controlling for those, they found that adoption of GMO corn was associated with a 17% increase in yield. And of course, the ability to account for weather is important, because if you recall, the previous study I mentioned indicated that we have reduced efficiency because of climate change already. So, that was a recent study that was focused on the US. Here, I'm showing you this figure on the right is a figure from a review study that synthesized results from 147 studies conducted in developed and developing countries. And it found on average that GMO adoption increased yield by 22% while reducing pesticide use by 37%. On the left here, this quotation I have has also been pulled from that 2016 NASEM report, okay? And what that report found, right, after thoroughly examining the evidence, is that there is strong evidence that BT applications have reduced pesticide use, okay? And so, and it's important to note here too, that BT crops are so effective at reducing insect pressure that there's also been a spillover benefit of reduced insect pressure for fields not planted to BT crops. So, while there's strong evidence that BT crops are associated with lower pesticide use, the evidence about HT crops is a little more mixed, okay? And so I've provided that quote as well from the 2016 NASEM report. And here I should note too that NASEM refers to HT crops as HR crops, which just stands for herbicide resistant instead of herbicide tolerant. And this report concluded that HT crops were initially associated with a decrease in the amount of pesticide applied, but that reduction in pesticide use has not generally been sustained. But I also wanted to include in here, a little bit more context, because they do provide this recommendation, and I think it's important to think about this. And so really what this recommendation is saying is that really you've got to have a little bit more nuance than just looking at the amount of pesticide applied when thinking about the benefits of HT crops. And that's because HT crops allow farmers to reduce toxicity exposure by substituting to a relatively less toxic herbicide. This is relevant, right, to the environmental impacts of agriculture, because higher levels of toxicity increase the negative impact of agricultural production on the environment. Additionally, HT crops make it easier for farmers to adopt conservation tillage and no tillage. Some herbicides previously relied upon often required soil incorporation prior to seeding, and ineffective weed control caused farmers to rely on tillage practices as the leading option for weed control. The effective weed control of HT crops has provided weed control from one year to the next for some farmers, so much that it has allowed them to essentially practice zero tillage across those years. And reduced tillage has been reported in all major GMO crop producing countries. In 2008 alone, so taking all these factors together, right, reduced pesticide applications, the associated fuel use associated with applying pesticides, and the ability to transition to less toxic pesticides and switch to reduced tillage practices is estimated to reduce greenhouse gas emissions equal to that of removing 15 million vehicles from the road. And those results are just from 2018 alone. Okay, so from 1 year, it is equal to removing 15 million vehicles from the road that year. To end the section about environmental benefits, I want to bring attention to the GMO chestnut tree. The American chestnut tree was essentially eliminated by disease, and you can see an example of the disease tree on the image at the left. A GMO chestnut tree was developed to be to be resistant to blight and is presently undergoing risk assessments. And on the image on the left, you can see the GMO chestnut tree. And this ability, it's important because it's not just the ability to provide environmental impacts. This is an example of a GMO application that's helping to bring back biodiversity. And as we've seen with the rainbow papaya, there's also a possibility to protect biodiversity. So the final claim we're going to make today is that the slow and unpredicted pace of GMO crop regulatory approval is limiting investment in research and development. So the estimated average cost, that 136 million, I think it was 136, might be 138, but the large number I referenced last, 35 million of that has to do with regulatory science, registration and affairs. Okay, so that's about 25%, somewhere around 25%. Okay, and estimates indicate that regulation that acknowledges GMOs, that they're not riskier than conventional breeding, would more than double farm gate revenues, with the majority of these benefits accruing to developing areas. So not only are regulatory burdens costly, but they are particularly costly for those who can least afford it. And furthermore, the differences in regulation across applications and across countries creates a bottleneck in development and commercialization that ultimately reduces food security. You may have heard about the EU Court of Justice ruling to essentially treat gene-edited crops just like GMO crops, and they're going to regulate them the same. You may not have heard that this announcement resulted in firms halting investment, some firms halting investment in gene-edited crops developed for growing conditions in the EU. And producer surveys in the EU have shown that about a third are likely to adopt GMO crops if available. And the scientific advisors for the European Commission's group of chief scientific advisors recommended that revising this existing directive that currently reflects the knowledge, in particular for gene editing, is something that the EU should do. And as you can imagine, the high costs associated with regulatory hurdles largely preclude public institutions from attaining GMO approval for GMO applications. This is troublesome, right? Because the public is concerned about the distribution of benefits and corporate control of the food, yet there's little possibility for public institutions to bring a GMO application to the market. So, in closing, technological advancement in agricultural production has allowed humanity to increase the amount of food produced, yet it's not going to be enough, right? We need continued advancement. Decades of evidence and statements from nonprofit and scientific organizations highlight the safety and positive effects of GMO adoption. Consumers have historically received benefits from GMOs in the way of lower prices. However, applications, are now being targeted at consumer issues by micronutrient deficiency, and these applications will, of course, increase that proportion of benefits received by consumers from GMO applications. The benefit of GMOs to producers is apparent, right? Especially in the US. I mean, you wouldn't see 90% of the acres being planted if that weren't the case. However, the health benefits of BT applications provide, vital health benefits to producers in developing areas. Compared to the non-GMO alternatives, GMO applications use less land, energy, and chemicals, and thus the carbon footprint of agriculture would certainly increase if GMOs were not available. Finally, inconsistent regulations do not reflect scientific evidence and have high costs for society, particularly those populations in developing areas. Thank you.
Thank you, Dr. McFadden, for an excellent presentation. As we are transitioning to the discussion panel, I'd like to share some information with you about some upcoming publications that we've got coming up in early 2022. The first of those being a paper on the goals, strengths, and limitations governing the use of life cycle assessments in food and agriculture. Another paper that will follow shortly behind that is a paper on RNA interference technology in agriculture, the methods, the application, and the governance of this technology. And another paper we'll be excited to share in the spring, the environmental, social, and economic impacts of implementing sustainable intensification in agriculture at scale. These are papers that are, again, being developed by volunteer task force of scientists and other subject matter experts, and we're looking forward to bringing those to you as far as. Additional information about CAST activities can be found on our website and through our social media, and I encourage you to follow us on those platforms. Brad, at this point, I think I will turn it back to you, and we will bring down the presentation, put up the pictures of our panelists, and start the Q&A. And we've got a few questions ready for them to respond to.
Excellent. Thanks, Kent. Well, I'll just start with the first one here on the list. And I'm sure a lot of the panelists will actually have good food for thought on this. So what do you believe is the best way to convey how safe GMOs are and why they're good to use? Through publications, social media, webinars, presentations, etc.? Yep, Stuart.
Thanks, Brandon. I think probably one of the important ways is for the entire ag innovation pipeline to start talking about what they're doing. You know, certainly even at the university R&D level, we need to be more transparent about, you know, why are we developing new crop varieties? What type of research are we learning? And, you know, a lot of the people on this panel do a great job of communicating on social media and through mainstream media about the importance of this, but it extends through the food processors too, to talk about important technologies that increase the shelf life of food products and help keep price increases at a minimum. So I think the responsibility lies right across the entire ag pipeline.
I might jump in and say, maybe it's a strange thing to say for a council for agricultural science and technology, but often communicating the science, and you often hear people say this, we just need to educate the consumer. I think the science of communication suggests that's not a particularly effective way of getting people to change their mind necessarily. So, you know, people change their minds because of the cultures they live in, the people they interact with, who they trust. Understanding that dynamic and the culture in which people make decisions, I think is critically important. And I don't want to say the science doesn't matter. I think the science is critically important, but it's not enough just to say, here's what the science says. That's not going to change almost anybody's mind, as we're seeing today with debates about vaccines effectiveness and mask wearing and all the rest.
Yeah, and I think it's important to note too, you know, Jayson and I have done some survey work where we asked people why they would desire GMOs. And just so you know, herbicide tolerance is the last reason why they would want it. And so all that to say that, you know, the early applications weren't targeted at consumers, right? They were targeted at their consumer, which are ag producers. And so also I think just as things evolved and, you know, so some of the second generation applications and things are more targeted towards consumers are going to, it's more, the benefits are more obvious, I think. And right now they're a little convoluted for consumers.
Brandon, can I add one thing? I think a lot of the issues around the beginning of this whole debate, whenever you say that was in the 1980s, was about this is the way it is. This is the way we've decided it is. And this is what we're going to produce. And people were encouraged to push back against that position. I think it's always a trade-off. And if we don't present it in the context of trade-offs, yes, we will not genetically modify bananas, but you do understand we won't have bananas, is the coldest trade-off you might want to make. But those kind of trade-offs are not getting across to consumers so that they understand the implications of a no vote.
No, I agree. I 100% agree. And so we could broadly say connect on values, right? And the value is we like bananas and we prefer the bananas to be around. And I would agree that the ability to do that, right? Even the story of the papaya, likely very low number of people know that story, but they would find a lot of value in that story. Jill, do you have something to add?
Yeah, I was just going to say that the media often has a bias towards reporting bad news, and similarly, there is generally more negative news about risk on social media than positive. So that's just something that needs to be overcome. Another thing, I think that people, whenever it's from industry, they often view it with skepticism that the industry is trying to sell them something. It seems like something that often works better is when you actually feature farmers. You might feature this farm family, and this is why we chose to use biotechnology or the GM crop, and this is the benefit if you actually have individual farmers rather than a big corporation, which consumers are very skeptical of.
Mm-hmm. Alison, I know you've done a lot of work here. Do you have anything to add before we move on?
It's a tough nut. It is much easier to scare people and to reassure them. And, I think the truth be told, there's industries that are able to monetize that fear. And they often have quite well-oiled publicity machines that is really, the only people fighting back against that is really public sector scientists who kind of do this on the weekends. So I think it is a little bit of a difficult space, just because if industry says anything, no one believes them. When I'm talking industry here, I'm meaning the biotech industry, but the fear-mongering industry have free access to say things. And I've found it very frustrating that getting involved in discussions that aren't in good faith, like there's no actual attempt to respect what the data says, and there is it's intentional misinformation to try to advantage certain products in the market, and it's just really hard for science to fight that, I think, because we're not allowed to lie, and that just makes it's a boundary that we can't cross, and it makes it more difficult to have the discussion when someone's talking about something giving you, I don't know, cancer or something. It's hard to fight that back. It's a very scary sounding thing.
Yeah, real quick, that's a great point. And I want to build on that, because organization, we just recently caught some flack from an organization because we have a grant about gene editing to communicate the science. And the group that we're catching flack from is working to minimize the science. And then when we work on it, we're USDA's mouthpiece to sell the science, when we're really combating the scenario that they built, right? So it's kind of this endless snowball cycle that continues. So even when you try to communicate the science, it gets lumped into all that. All right, go ahead, Farzad.
Yeah, so my point here is that we understand that how the media is working, how they are interested in bad news and scare people. We understand those. And that will probably make our jobs more difficult in terms of communicating with the media, in terms of expressing the results of our research community. So I think we need to work more on that side to make a better bridge between the scientific community and public media, and inform the benefit of these kind of GMOs and other technologies, related technologies, in a way that the public media can handle that.
Exactly. Thanks. So I'll move on to the second question, and Stuart, looks like that you're ready to grab this one. Maybe is that, are the costs of bringing a GMO to market now lower thanks to streamlined processes in USDA and EPA for familiar similar products? Thank you.
Yeah, I saw that. That's a good question, and the 136 million is a global cost. So if a product's commercialized in the United States, it needs to be approved for import into trading partners with the US in that commodity. So it's great that the EPA and the USDA are streamlining their regulatory systems, but the cost is really not going to change any, in large part because of the EU, and the costs just keep going up to get varieties approved for import into the EU.
I'm not sure if anybody else has anything to add on that, but I think we would all like to see an updated study that was similar to the older one, because like I said, I think the data was 2008 to 2012 was for traits that were developed or approved during that time frame. And I think we would all like to see some updated numbers on that. Jayson.
I'll just make a comment, maybe a little bit related to what Ellen said, that, you know, that everything involves trade-off in terms of, including cost of regulation. I mean, I think, you know, we want a regulatory system that consumers can trust and they can feel safe about their food, and that will entail some costs, some regulatory burden. One of the challenges, though, is if you build that cost high enough, it prevents new entrants from entering this market. And as you noted in your talk, Brandon, one of the concerns people have with GMOs sometimes is the concentration issues involved in the sector. But the higher the regulatory costs, the higher that burden, the harder it is for these new startups, even university professors, to commercialize their applications. And so that's, you know, there's not a right answer here, but there's certainly a trade-off there one has to keep in mind with regard to those regulatory costs. And one of my concerns regarding those is we do keep out a lot of technologies that could be interesting and very innovative from a lot of people I think would be, the public might be very sympathetic to.
Anybody else have anything to add before we move on to another question?
I guess I'll just say that we just did a paper that looked at the opportunity cost of foregone applications, basically the trade-offs in economic jargon of not allowing products to come to market. And because any regulatory delay has to be balanced against, well, what are the benefits you got from that? And that was published recently in the annual reviews of animal biosciences. And they're pretty substantial when you're talking about applications that could address things like animal disease resistance, where if the animals keep getting sick because you're not allowed to adopt a genetic approach to solving that disease, then that opportunity cost is really big. It's not obvious to people because the disease keeps happening, and it could have been prevented. And so we had a little bit of a look at that, and so it's true in the animal space as well as in the crop space.
I was going to say, Alison, while we've got you unmuted, I think this is one that you can help with. Are there animal GMO technologies in the pipeline that could significantly reduce methane emissions from livestock?
So the term GMO always is kind of like, what are we talking here? Genetic engineering or gene editing? Or so that's a little bit of an amorphous term. I think specifically as it relates to the methane emissions, they're coming from the microbes in the rumen, right? That's who's making methane when they digest cellulose. And there are some people looking at that. I guess I would push back a little bit as an animal breeder and say, my gosh, there's nobody that's delivered more methane emissions per unit of product than conventional breeding has in terms of improving the overall efficiencies of, a cow today makes 4 times more milk than she did 50 years ago. So you need 4 times less cows to make the same amount of milk. And so those are the types of kind of improvements that conventional breeding can make. And I guess to me as a geneticist, these additional technologies of genome editing and genetic engineering just add a little bit more power to that conventional breeding to reduce these things. So I guess the short answer is there's nothing I know of that's actually editing the animal to reduce methane emissions other than the efficiencies. And there is certainly work being done for feed additives like seaweed to reduce the actual methane production by animals.
Thank you, Alison. Anybody else have anything to add to that one? So there's an interesting question in here that I'd like to get to. So it says, I understand GMO is safe. However, how does GMO impact consumers who have preference restrictions to food source because of religious reasons? Once genes are altered or introduced from other sources than their native genes, how do consumers continue their religious practices? And then they ask labeling. So I think this is a great way to to comment on horizontal gene transfer, which I can try to do. as an economist, but I don't know if anybody else can do a better job, but I'd be happy to take a shot. So essentially, as it's becoming more economically feasible, so I can work that in there, to sequence genomes, we're finding more examples of horizontal gene transfer. So this idea of other things, one entity introducing DNA, right, themselves into another entity, we're learning happens. And this is another issue with consumers, and I think people in general, is we kind of have this what's called a nirvana fallacy, where we think there's like this perfect world that used to exist and we somehow departed from it. And everything we do is some departure from this perfect world that exists. But the case is, everything is trying to overtake everything else. And hopefully COVID-19 is some wake-up call that everything is trying to outcompete everything. And so we see evidence of horizontal gene transfer, right? And so this is something that exists before GMOs.
I might comment here, Brandon, too, that this really, I think, is a good example of your comment that a GMO is not a single thing. So I'm not personally aware of any religious belief that would be against a plant producing BT, let's say, or provide, conveying herbicide tolerance. One might have a theoretical objection to, say, the introduction of a shellfish gene, for example, certain religious beliefs, or a gene from a pig, for example, kosher or halal. But that's a theoretical possibility. To my knowledge, that hasn't happened in any of our current foodstuffs. I think that question also had a question about labeling. In many parts of the world, labeling is mandatory. Here in the United States, it's about to be mandatory in about a month or two. So one can check packages. I think one of the really cool things I'm starting to see on food packages with these QR codes that are disclosing, you can click on those QR codes and it tells you actually a lot more about ingredients and ingredient lists that would ever be printed on the back of a package. So, were someone to ever do that sort of thing, it might be the kind of thing that they would disclose in a QR type code setting.
So let's stay on labeling, actually, because there is a question about labeling, if that's all right, unless someone else had something to add on that previous point. So this question asks, GMO labels are starting to appear in large numbers. I've been noticing them and have seen others sharing some that they've found. What is the prediction for how this alters the understanding for consumers? And they've got a link here, but I haven't been able to click on it yet. But they found one that made them laugh. I'll try to find it.
I don't want to dominate the discussion, but I love this question. And I think I've always wondered why some food processor company didn't take a stance 10 or 15 years ago to make a label that says, we use GMOs and we're proud of it. Like, you can make that case. And it was always curious to me that somebody didn't carve out that market segment in a way. But I think, as I just alluded to now, I think the door is really wide open for people to communicate a lot more than they did before, mainly through the use of these QR codes. I'm seeing it already in food packages. So maybe it's just me, but when you start seeing these QR codes, scan them, see what they say. They're kind of neat in terms of what people are saying, not just about GMOs, but other ingredients and products. Like, it'll explain, here's what the scientific word for this is, here's why we're using it. It's actually quite helpful.
Brandon, we did a consumer survey in Canada a couple of years ago, and we found that respondents said they would be willing to pay the same price for a GM food product that contributed to reduce GHG emissions or less chemical use. And so they were, as long as it wasn't priced more than a conventional non-GM product, they would be happy to buy those products with those environmental labeling attributes. So, Jayson was talking earlier about the importance of the environment, so that there might be an opportunity to start environmentally branding why GM is a beneficial technology.
Yeah, and to that point, Jayson, I was in middle school in 1994, but I have found images online that the Flavor Saver tomato did just that. Like, even in some of their processed things like tomato paste, that they were labeling it at the time. But if you look at the consumer research back then, the early consumer research of that time, people were very positive actually about GMOs.
I wasn't in school. I was working at Cogene, and quite frankly, we loved it. We bought it here at the local supermarket, and it was always kind of perplexing to me what happened between then and now that it became the enemy. And it was a little startup company with basically theoretically a consumer benefit. Whether you like the taste of the tomatoes or not, it's a different matter. But it was the first product, and often you hear the narrative is the first products were, you know, Monsanto stuff, and it's like that's actually not true. It was the tomato and the papaya. So yeah, it's frustrating that the discourse went the way it did when it started out so positively.
Jill, do you have something to add to?
Well, I was just thinking, ex ante, I predicted that consumers would view it as a warning, because otherwise, why would the government require this label? I don't know if I think the jury's still out on what the long-term effects of having more GM labels, you know, and once it's mandatory everywhere, it'll be interesting. Maybe people will just get more used to it. But then at the same time, during the pandemic, I've also seen some work that more people are buying organic too, which is the non-GMO version in the US.
Ellen, did you have something? It was like you're unmuted.
I was just going to say that whenever you ask the public anything about information, they want it.
Yes.
Doesn't mean they're going to read it, doesn't mean they're going to study it, doesn't mean they're even going to check that it's there, but the knowledge that something is not being denied them is a positive that people get out of this. So I would really like, somebody suggested that we should do more of the positive stuff that Stuart mentioned, and I think we should experiment a bit more with that, because it would be nice to see if that worked. But I do think that some of the commercial providers of information, when for some reason they've chosen to provide it, have not suffered in terms of sales from providing the information. So maybe just knowing it's there is a good thing.
Brendan, I hate to cut off a good discussion. We're running close to our time, and I want to thank you, and I want to thank all of the panelists for your comments and joining. As mentioned earlier, this is going to be recorded, and if you haven't seen our paper yet, the paper that they're referencing, this is where you can find it on our CAST website, and also I've included information if you want to follow up with any of our panelists today about specific questions. We have captured the questions that were shared in the chat, and we will be circulating a document to the authors to gather up answers to those. And we will be posting that on the CAST website along with some other resources related to this paper. So again, thank you to our panelists. Thank you to you for not only being here today, but the work that went into writing this paper. And I'd like to thank all of you who joined us today for this webinar. Appreciate your participation, your interest in this topic. Again, please look to CAST as your trusted source for science, and visit our website. Look at not only what are our recent papers we put out, but you'll also find information on some of our upcoming papers, as well as some of the things that we're doing to solicit input and feedback on how we make CAST a better organization, particularly as we think about the next 50 years and what are the challenges that we will be facing as we think about science, communicating the science, technology, and innovation of food and agriculture. So again, thank you, everybody. Thank you for joining us, and have a great day.